All right, welcome back. Now, as I said in the last video, graphing tangent functions is very similar to graphing sine and cosine functions. You got to find the critical points, right? And so the critical points you have to find for graphing tangent are you have to find two asymptotes and the intersection point, okay? The x-intercept, okay? So, now you can find the asymptotes easily by solving the argument here for pi over 2, right? Because we know for tangent x, it's going to have an asymptote at pi over 2, right? So we start with that, right? And we know that there's also going to be an asymptote at negative pi over 2. So why don't we solve for those two? If we have something like this, right, why don't we just solve for the value of tangent where this argument equals each one of those. So we'll do bx minus c is equal to negative pi over 2, and then bx minus c is equal to positive pi over 2. Okay, so that'll give us the two asymptotes. What else? Oh, okay, so the intersection point, we know that the intersection point is going to be halfway between the two asymptotes. So wherever those asymptotes lie, all we have to do is find the midpoint of that range, and that's where the intersection, the x-intercept, is going to occur. Now, the period of the function is the distance between two consecutive vertical asymptotes, right? We know in general that the period is pi, right? But in general, remember, it's going to happen, the period is going to happen between two consecutive vertical asymptotes. That is going to be the period. Now, the amplitude is undefined, right? There is really no amplitude that we can define here because it goes off to positive infinity and negative infinity in the y direction. So since the range is all real numbers, the amplitude is undefined. Okay. Let's see. Now, as far as plotting this goes, really all you have to do is plot the two asymptotes, so two consecutive asymptotes. You want to plot the x-intercept. You also probably want to plot a couple of extra points on either side of the x-intercept to get more of a feel of how this thing looks and behaves. And then once you have a few more points plotted, then you just connect the dots. And you probably want to plot maybe one or two or maybe even three cycles of the tangent function. I mean, you don't have to, but typically at least two would be good. So that way you could see the pattern. Okay? Let's see. What else do I want to do? Okay, that's it. I think. Yeah, I think that's it. We'll come back and do an example.